Okay. So I tracked the past papers only from 2016, 2015, and all. I didn't check 2015 and all. So 1, 2, 3, 4, 5, 6, 7, 8, 9 past paper years. I have checked 2015 kinetics I saw. Right. So the thing is, people, last year they gave this one. And I knew they will give this. Why? It was like a long time back since they gave PH and KSP. It was like 2020. So it was one of the guesses to get PH and KSP in the 2024 paper. And then 2025, what are the possible things which we can get for 2025 structured essay question number 3? We can't guess. That's the first thing. We can't guess properly. ඒක guessing එකක් නෙමෙයි මම මේ කරන්නේ. I'm just giving you a question practice. මං කියන්නේ නිකන් මේක ඇවිල්ලා මේක එනවා මේක එනවා මේක එනවා. Go and look yourself. එහෙම නෙමෙයි මං කරන්නේ. I'm doing a question practice here. I'm making you practice for the most probable questions to come. එතකොට මෙතන PHKSP නෑ. In this tute I have given you in the PDF, there is no PH and KSP. එතකොට PH and KSP, where I am doing it? In the paper class I am doing it. Paper class ATP papers. Advanced level target papers. So those papers includes PH and KSP. एक papers පහක් කරනවා. So there are 5 more structured essay questions in that, and it includes PH and KSP too. එතකොට if they give PH, they should give KSP. Like it goes together sometimes. Like most of the time, it goes together. You have seen an MCQ pattern in 2024. MCQ number 504, 7, I guess, 7 or something. There was a question from KSP and PH combined. How is KSP and PH combined? So normally when they give PH, they will give KSP. Even in an essay question, it's like that. If there's PH in the paper, there's definitely KSP in the paper. Hari. So this year, what can we guess? Okay, first of all, kinetics. You can see kinetics was given in 2016, and then no kinetics, no kinetics, no kinetics, no kinetics, no kinetics, and then here kinetics, and then now 2025, will there be a kinetic question? So before kinetics, people, the most probable thing which you can get is this. You can see 2018 only they have asked a KPKC question, and then after that, they haven't given anything in the past few years from KPKC. So most probable question is KPKC. If I would say most probable, there is no like guaranteed, I can't guarantee it, but most probable is KPKC. So KPKC I'll put on top. After that, kinetics, right? No, Raoult's law, this one, Raoult's law. Raoult's law was given one time in the last 9 years, and it was 2021 they gave it last. So Raoult's law givuhama, what you have to remember is the phase diagram. Can you remember phase diagram of water, phase diagram of carbon dioxide, something like that? So there's a question here in the tute. So phase diagrams, you have to keep an idea on that, like keep an alert on phase diagrams, like marking phase diagrams, and then like it could be an MCQ also. It could be MCQ, it could be in your essay paper, it could be in your MCQ paper. Because essay paper and phase diagrams I have seen, right? They have given it before. However, for the structure essay question, this could come. How the phase diagrams could come. And then third one is Raoult's law. There is a probability to give Raoult's law, right? Or a phase diagram. අර කොළේ වගේ ඇවිල්ලා they will ask what is the boiling point of this, what is the partial pressure of this, and a calculation related to diagram, right? Calculation related to a diagram අර මේ වගේ ඒවා තියෙන්නේ like this boiling point variation, that one. From that they can give a question. From that they can give a question because in 2021 only they have asked, and that's the only question for the last 9 years. So yeah, after that, I would guess something like energetics. Now you will be like, Aya, now you're telling all the physical chemistry units. Mama eka නෙමෙයි කියන්නේ. I'm telling a priority order, right? Most probable KPKC, then phase diagrams, and then Raoult's law, and then energetics. Energetics and gases most of the time goes together, but we can't tell it like that. Raoult's law and gases together also can combine. Energetics and gases also can combine. So it's just a probability. Before energetics, people, kinetics. I forgot that. Kinetics is a probability which comes above energetics and then gases. මේ gases කිව්වහම ඔය එක එක ඒවට combine කරන්න පුළුවන්. Raoult's law එකට combine කරන්න පුළුවන්. Energetics වලට ඒ කියන්නේ part A part B දෙන්න පුළුවන් gases දාලා. The thing is if you get one of these topics for a structured essay question, you won't see that question in the essay paper. You have to keep that in your mind. If they give energetics for the structured essay question, there won't be an essay question from energetics. ඒක මතක තියාගන්න. හරිද? ඒක that will help you to like study these things because you might think now pH it might be a essay question. හරි most of you are not good with pH. එතකොට මම දන්නවනේ like even my friends those days they hated pH. They didn't even look at pH. pH කියලා දැක්කම අම්මෝ pH කියලා හැබැත් හරවනවා. අර එහෙම උන් ඉන්නා හරිද? pH පේන්න බැරි උන් ඉන්නවා. හැබැයි last year if they didn't study pH then you can't do the third structured essay question and that's a big drawback because that was one of the hardest question and if you could do that your Z score will go up. Why? You will be able to do something which other people can't. That is how you increase your Z score. හරිද? You are not selected to campus because of AAA. හරිද? A තුනක් දාලා campus යන්න හිතන්න එපා. Colombo people especially some people have 3 A's but still can't go medicine. There are people like that. 3 A's and still you can't go medicine. Why is that? Is it score not enough? Your A level is like 75, 75, 75 maybe. 3 A's tibba gela you can't go medicine. Like if your target is medicine, of course, like most of you are like that, and you are inside a frame and then you think medicine is the best thing. So yeah, if you can't go medicine because just you have 3 A's. That's not possible. Then what you should do? You have to do something which others can't. You have to do things which others can't do. Physics mostly. ගොඩක් කඩේ physics A percentage is like 5%, 6% for physics. In 2015 it was 3%. Imagine 2 to 3% A percentage in 2015. Physics. So your most prioritized subject, bio people especially, physics. Maths people, chemistry කිව්වට එහෙමත් නෑ බියවලා මේ maths කට්ටියට physics වලට ලකුණු තියනවා නම් like they will get a higher Z score. I'm telling this with 2 years experience. I did A levels for 2 years. So 2 years I'm telling may first thing physics, second biology for bio students biology and then third chemistry like priority order. For maths people first one is physics, second one is chemistry and third one is maths because maths won't give you a higher Z score even if you score much. එක පොඩි එහෙම එකක් තියෙනවා. අර maths වල මේ standard deviation එක මේ වැඩි. මොකද බිඳුව ගන්නව ගොඩක් ඉන්නවා. The thing is maths doesn't have MCQs නේ. Mathematics doesn't have MCQs. Physics මේ මොකද මේ pure maths මේ applied maths දෙකේම paper එකේ MCQs නෑනේ. They don't have MCQs. So there are people who get 0 marks and closer to that. But in bio paper you have MCQs. කනා shot හරි ගහලා copy කරලා හරි ගහනවා ලකුණු. හරිද? At least they will get a 20 at least they will get more than 10 නේ. 50 MCQs they will get more than 5 probably. කනා ෂොට් පහක් හයක් විතර වදිනවානේ හරිද? ඉතින් මේ මැත්ස් කට්ටියට කනා ෂොට් කියලා ගන්න නෑ හරිද? දැන් මාර කරුමේ අර පොඩ්ඩ අර බිඳුව ළඟට ලකුණු වැඩි. That is why the standard deviation is larger and the Z score is like if you get an average marks for mathematics your Z score won't change much. That's the thing. So yeah, you have to do things which others can't do. ඒක නෙමෙයි කතා කරන්න ආවේ. මේක කතා කරන්න ආවේ. හරිද? So yeah, so these are the possible things which you can get for the third structured essay question with most of the attention to KPKSV and then phase diagrams and Raoult's law. Most of the attention is given here, but I don't say these won't come. These also could come. We can't guess the paper. That's the thing. We can't guess the paper. 2024 physics paper they have given meter bridge, and then 2023 paper also they have given meter bridge. Latent heat of vaporization practical 2022 given for physics. 2024 also given for physics. We can't guess the paper now. Professors are playing with us, so you can't guess. This is a guess session just for question practice. This is not like I'm telling you the topics and then you are like, okay, I at all this is coming, so I'm studying only that. You can't do that. You can't do that. You can't blame it on me if it doesn't come. What I'm telling is just a method to just focus on most important parts and then මේවත් කරන්න. I'm not telling not to do. You can do everything and go to the exam. But pay more attention to these parts. මේකෙන් නම් කොහොම හරි එකල හුණක් හරි එනවා phase diagrams වලින්. At least 1 mark you will get from phase diagrams either in the structure essay, either in the essay, either in the MCQ. ඔය තුනෙන් එකක් අනිවාර්යෙන් එනවා කියලා මට හිතෙනවා phase diagrams. So yeah, take the first structured essay question, that is Raoult's law. Raoult's law and phase diagrams combine structured essay number 1. Here solvent P and Q get completely mixed to make a binary ideal solution. How is this binary ideal solution? This solution was allowed to attain dynamic equilibrium in a closed container with its vapor phase. Hari. Solvent P and Q. So there's P and then Q. Completely mixed to make a binary ideal solution. So ideal binary solution, you know what's that? The solution was allowed to attain dynamic equilibrium in a closed container, right? That's a closed container with its vapor phase. Derive the following expression for molar fraction of P. Okay, XP in the solution. Let's put it as liquid solution. XP liquid is equal. You have to write it as solution. Na? Like if they have given XP sol like this, you have to write it as XP sol. You can't put your own things. If they have given it like that, then you have to use that. But I am using this one because it's easier for me. I am not the student who is writing the exam. So you can write the sol here. Is equal to delta PQ. This is the vapor depression. This is the depression vapor pressure. And this is P naught Q. This is the saturated vapor pressure of Q. I hope this is like yes, Hari. Okay. So this is Raoult's law actually, people. This is the second representation of Raoult's law. Which year is it? This is not a past paper. This is not a past paper. Hari, may this is not a past paper. I have given the PDF in the groups, so you can. Sir, can you please explain how to increase MCQ counter? Right now, I won't be able to tell that. I have to do this. I will tell at the end if I have time. Okay, remind me. Right. So this is representation of Raoult's law, and this one I have given in the roots. Make a deal dena. I can make a derive karna hati. I can representation of Raoult's law කිව්වම දෙකක් තියෙනවා. හරිද? මේක අනිත් එක. The relative depression of vapor pressure of one component in the gas phase is equal to the molar fraction, molar composition of the other liquid in the liquid phase. අන්න එහෙම කියන්න බලන්න. හරිද? ඒක තමයි මේ අනිත් එක. එතකොට මේක derive කරන්නේ කොහොමද? So people, we can write the depression in vapor pressure, delta PQ will be the saturated vapor pressure minus the current vapor pressure. Pure solution එකක් තියෙනවා. There is a pure solution of Q. Pure solution of Q. There is no P here. So here people, you get the P naught Q when it is like alone. And then you mix them together like here. Then you mix them together. And here you get PQ. This is not saturated. This is saturated. So you know when it is like mixed with another component, the pressure reduces. Right? It's like P naught Q minus PQ. And this is a positive value. So yeah, PQ is lesser than P naught Q when it is like mixed with another component. It's like you people. Again, when you are like alone, your performance is high. But when you're with someone like friend or someone, your performance is less. This is not true for some people. Some people like they work with friends a lot. I'm telling like average, most of the students, if you like connect with your friends, then you can't do anything. They are talking, shouting, and then telling gossips and stuff. So you won't be able to study. So your pressure will reduce actually. Your level will reduce and they will drag you down. I'm not telling everyone, okay? Some people are good. People, we can write according to Raoult's law, PQ is equal to molar fraction of Q, XQ in the solution. I'll write liquid. How is the liquid times P naught Q. This is the saturated vapor pressure. And this is the molar fraction of Q. How is XQ? And this is the pressure of Q in this solution. How is right? People, I also know this thing. XQ liquid plus P liquid. Again, mole fraction of P and mole fraction of Q. If you add them together, you are getting 1. Done. This is like normal thing. So XP liquid will be 1 minus XQ liquid. 1 minus xq liquid. xq liquid එක subject කරන හරි නේද? හරි. Now I can substitute this one to here. හරිද? I can substitute this one to there. So PQ is equal to 1 minus XP liquid. 1 minus XP liquid is equal to P naught Q. So PQ is equal to P naught Q minus P naught Q XP liquid. Hurry. I can take this other side. P naught Q XP liquid is equal to P naught Q minus PQ. You can divide this by the partial pressure, then you get XP liquid is equal to P naught Q minus PQ divided by XP liquid. So here you go. This P naught Q minus PQ is delta PQ. XP liquid is delta PQ divided by P naught Q. We did this in class actually. In the class tute you have this. So this one you can get in the paper. So please have an attention on that. And also people do that 2021 question. Exam එකට යන්න කලින් 2021 question එක කරලා යන්න අර මේ මොකද boiling point variation වලින් දීලා තියෙන question එකක් fractional distillation that one. හරිද? You can check that question pattern also before going to the exam. There is a probability for that. I haven't given a question from that ඉතින් අර 2021 වල දීපු හින්දා මම ඒකෙන් දුන්නේ නැහැ, but you can look into that. Then second Roman number. Consider the following information regarding P and Q. At 298 Kelvin, saturated vapor pressure of POP is 52 kilopascal. POP, okay? Total pressure of the equilibrium liquid mixture of 2 moles of P and 3 moles of Q is 37 kilopascal. Okay. Calculate the saturated vapor pressure of POQ. Calculate the saturated vapor pressure of POQ. Can I erase the board, people? Can I erase the board? Okay. So what do I know here? I know the saturated vapor pressure of POP. P naught, P I know. And the total pressure I know. PT of the mixture I know. And I know the mole fractions of each gases I know. PXP also I can find out. And then XQ also I can find out. So I can do that also. They're asking me to find saturated vapor pressure of Q. They haven't given the pressure of P, right? So I can find the pressure of P first. I can find the pressure of P first. PP. TP is equal to total pressure of the equilibrium liquid mixture. Liquid mixture එකේ තමයි දීලා තියෙන්නේ. So I can apply Raoult's law. If you now since they have given it's an ideal mixture on the top people part එකේ උඩ දීලා තියෙනවානේ. It's an ideal binary mixture කියලා ඒක හින්දා ඒක ලියන්න ඕනේ නැහැ. ඒ කියන්නේ මේක දීලා නැත්තම් question එක. If the question they haven't given it, then you have to write assuming this is an ideal binary solution applying Raoult's law. You have to write that thing definitely in the exam. So here I am writing applying Raoult's law. So when you're applying Hess's law, applying Raoult's law, applying Henderson equation, likewise, you have to write it in words. Applying Raoult's law. Applying Raoult's law, PP is equal to XP liquid. I have told you in class, when you're writing this equation, people, you have to write it such that the X value here, the mole fraction, you have to put it as liquid. Because in Dalton's law of partial pressure, you are considering the mole fraction of the gas phase. The ඕක පැටලෙන්න පුළුවන්. හරිද? ඕක පැටලෙන්න පුළුවන්. ඕක පැටලෙන්න හින්දා තමයි මම කියන්නේ මෙතන liquid දාලා කරන්න කියලා, right? Because otherwise you will mix up if you don't do it otherwise. So let's calculate this XP liquid. We can find mole fraction. We can find 2 moles of P. So 2 divided by 5. 2 divided by 5 multiplied by P naught P, 52 kilopascals. 52 kilopascals. 2 into 2, 4. 5 into 2, 10. 104 divided by 5 is equal to 5 times 2, 5 times 0, 20.8 kilopascal. So this is the partial pressure of P gas. Partial pressure of P gas. People, I can find the partial pressure of Q gas by subtracting the total pressure minus partial pressure of P. So total pressure here, they have given it as 37 kilopascal. So 37 kilopascal minus 20.8 kilopascal. So that's going to be 16.2, right? 16.2 kilopascal. 16.2 kilopascal. That's going to be your pressure of Q. Now, they're asking us to find the saturated wave pressure. So I'm applying Raoult's law again. Raoult's law for Q gas. PQ is equal to P naught Q multiplied by XQ liquid. XQ liquid. P naught Q is equal to PQ, which is 16.2 kilopascals divided by XQ. XQ is, people, 3 over 5. XQ is 3 over 5. Now, if I divide this, I can get 16.2 multiplied by 5 divided by 3. Make it it's like going to turn it side. I got a 6, 7, 8, 9. This is divisible by 3. 3 into 5, 15. 1 remaining. 3 into 4, 12. 5.4. Then 5 into 4, 20. 2 remaining. 5 into 5, 25. 27.0 kilopascal. 27.0 kilopascal. There you go. kilopascal. Next one, they are saying part B. Part B got metan hadanna. Calculate the molar fraction of Q in the vapor phase. People, I know the total pressure. I know the total pressure. I know the partial pressure. Now I can find the mole fraction, right? By applying Dalton's law. If I apply Dalton's law, they're asking mole fraction of Q. So PQ gas is equal to XQ gas, XQ gas multiplied by PT. PT is the total pressure. So XQ gas will be PQ. The pressure of Q, I found it 27 kilopascal divided by total pressure. Total pressure, they have given it as 37. Very nice. Now you can just divide this and calculate. Make it uttare මොකක්ද දෙන්නේ people? $27 දෙන්නේ මේකට. අනේ Q එකටනේ people හොයන්නේ මේ saturated නේ. මේක හොයන්නේ නේ 16.2. හරි. This 16.2. මං අරක දැම්මේ මේක දැම්මේ. This is saturated wave pressure නේ. This is the partial pressure. So 16.2 divided by 37. What's the value? Anyone? 16.2 divided by 37. 0.4378. 0.4378 will be your answer. 0.4378 will be your answer. Can round off it and write 438. 0.438 කියලා ලියන්න බලන්න. Next question. State the assumptions that you used in the calculation 2 above. Right there. Right there. People, to apply Dalton's law. To apply Dalton's law, there is a necessity. What is it? To apply Dalton's law like I applied here, there is a necessity. First thing is you have to apply Raoult's law, you need ideal binary mixture. That is fine. Okay. To apply Dalton's law, what you should apply? What should be there? To apply Dalton's law. මොකද්ද තියෙන්න ඕනේ? Tell me, come on, quick. To apply Dalton's law, what should be there? Come on. Ideal gas behavior. Yes, very good. Aroni. So, Dalton's law of gas, Dalton's law දාන්න නම් අනිවාර්යෙන් මොකද්ද වෙන්න ඕනේ? Ideal gas එකක් වෙන්න ඕනේ. It should be an ideal gas right there. They're asking the assumption. Gases P and Q. Gases P and Q above the liquid phase. Gases P and Q above the liquid phase act as ideal gases. Act as ideal gases. එතකොට තමයි we can apply what you call Dalton's law. Otherwise, we can't apply. If it's not ideal gases, we can't apply. Okay, phase diagram of pure water is given below. Interesting. So මේ වගේ question එකක් එන්න පුළුවන්. හරි? මේ වගේ question එක මෙන්න මේකට සමාන question එකක් එන්න පුළුවන්. I'm not saying will come. It might come. Hurry. So yeah, next one. Let's go quickly. Come on, people. Part B. There is no specific time for the guest days. I can make a discuss කරන්න කියන්නේ මං guest days කරනවා. අර specific time එකක් නෑ. අර මම සතියේ ඕනෙම දවසක වගේ මට වෙලාවක් හම්බෙච්ච වෙලාවක මං කරන්නේ. Like I'm also having other stuff like මටත් තව වැඩ තියෙනවා. ඒතකොට මම මේකට වෙලාවක් හම්බුනොත් මං ඒ වෙලාවට දාලා කරනවා. හරිද? ඒතකොට අර specific time එකක් කියලා එකක් මට guarantee කරන්න බෑ. I can't guarantee a specific time, and also I know that one class per week is not going to be enough because I have to do more questions. Make guest days people, I have to do more questions in the revision class. And also like MCQ program will go in the next month, last month, MCQ program to increase your MCQs from like, if you have 10 MCQs, then 10 to 20, what you should do. 20 to 30, what you should do. 30 to 40, what you should do. 40 to 50, what you should do. අර මම හිටියේ මම A levels ලියද්දි ගිය අවුරුද්දේ මේ I was like 35 when I started my second shy. I was like 35 when I started my second shy. මගේ first shy එකේ MCQ 32යි. හරිද? First shy I had 32 MCQs. I got a P. හරිද? I wrote the essay paper. However, properly. හරිද? My Z score in the first shy was 1.2 or something. 1.2 or something. හරිද? I couldn't go to Colombo biological science or medicine, nothing. So I wrote it again. Second time I started with like my first paper I wrote, it was 35. I didn't study until my results. Until my results, I didn't study. So yeah, 35 MCQs. And then I increased this to 40. 67, 46, I guess. Oh no. 46 or so, I can't remember people. මට මතක නෑ දැන්. හරිද? like my friends also have 46, 47, 48. මං ඒකත් අහනවා වෙලාවකට. ඒතර මට මතක නැහැ. 46 or 47 I can't remember exactly. මේ 47 නෙමෙයිනේ 46. 46 46. 47 වෙන්න බෑ. හරි 46 MCQs මට MCQs හතරක් වැරදුනා මේ දෙකක් අර මොකද්ද මේ එකක් මම හිතනවා මං තාම හරි කියලා අර මොකද environmental question එකක් තියෙනවා 30 ගානක හරිද ඒකේ MCQ එකක් තියෙනවා still I think I am correct in that other 3 MCQs නම් I was like messing up with it හරිද I was like messed up with it messed up කියන්නේ මේ ගොංකම හින්දා වරද්දාවේ හරිද like overthinking and stuff statement type questions last 10 questions overthinking led me to there. So yeah, how to increase this one also? Like I have been through this path once. So how to go here? Mega Gatte people, not much special effort at the end. This was the result of working from the beginning. I worked from beginning and I got BBC without like a special push in the last months. Last few months, I didn't give a special push. I was like nobody's there to guide properly. Those days, I went to 3 English medium classes and then those like messed up with the syllabus and then finally I couldn't cover the syllabus properly, chemistry and all. Bio was worse. Last 5 units, I never understood. I couldn't do it properly. එතකොට මේ this is what I got. C is for bio. First try. හරිද? This is what I got. මේ in the first try. එතකොට මේක මට අවුල් ඉතින්. මම I could go to a university like very what you call rural university. I can't go there because I don't like it. So yeah, I did it again. And yeah, that's it. මේ මුලින් ඉඳන් වැඩ කරාටත් මදි. අන්තිම කාලේ පොඩි පුෂ් එකක් දෙන්න ඕනේ මේ පොඩි හොඳ පුෂ් එකක් දෙන්න ඕනේ in order to like reach your target. Whatever your target is, your target might not be medicine. Your target might not be something like that because I myself in my second try I got ABB and this was chemistry. With this and all, I got like A for chemistry. And then my Z score 1.7 approximately, 1.6978. So around this, close to this. එතකොට මේකට medicine අර එන්න ඕන එකට යන්න ඕන like from Kandy. In other areas you can go with 1.7 like Puttalam side, Ratnapura side, whatever it is. Other sides you can go but in Kandy you can't. Colombo, it's like 1.8 or 9 or something. මම හරියට මතක නැහැ 1.8 or 9 or something. Closer to that. එතකොට it's not easy in Colombo and all to go medicine with an EZ score like this. So you have to like මේ දෙකත් ඒකක් කරගෙන තව ටිකක් ලකුණු වැඩි කරගන්න ඕනේ මේ එතෙන්ට යන්න නම්. හරිද? It's not easy. So last month, can we go from C to A? Yes, possible. So do we have time for going from A to C now? මෙහෙමයි. A cannot be guaranteed, but you can go for a B. හරිද? C to B is easy. A is not guaranteed. A comes with luck. අර C to B අවුලක් නැහැ. If you work with your maximum, you will get a B definitely. Maximum effort, B is definite. A එකට යන්න, you should have some luck. හරිද? ඒකට යන්න රොඩාරනේ ලක් එක්කුත් තියෙන්න ඕනේ මෙතනින් මෙතෙන්ට අදින්න නම් because it's not like you think. To tackle the exam stress at that moment, you should have proper practice. හරිද? හරියට practice එක තියෙන්න ඕනේ. Question handling, question pattern recognition, everything runs in your mind. හරිද? You are like, what will happen if I get a C? හරිද? ඔය ඔක්කොම ටික ඔළුවේ ඇතුලේ දුවනවා during the exam. So if you are proper oriented and like you have studied properly, that means මෙතෙන්ට යන එක අමාරු නෑ. But if you are in a C at currently, මෙතෙන්ට යන එක අවුලක් නෑ. මෙතෙන්ට යන්න චුට්ටක් ලක් එකත් එක්ක extreme effort එකක් දාන්න වෙනවා. Because ඔයා ඉන්නේ මේ border එකේ නම් exam එකට යද්දි ඔයා මේ border එකේ ඉන්නේ. හරිද? border එකේ කියන්නේ ඔයා මෙතෙන්ට අදින්නත් පුළුවන්. Like AB border. If you are in AB border nearing the exam, that means if you like do not panic and then do the things exactly like you wished for, you can go for an A. හැබැයි මොකක් හරි වැරදිලා panic වෙලා මොකක් හරි අවුලක් වුණොත් you will go for a B. හරිද? මේ border එකේ ඉන්න එක very unstable. හරිද? You have to increase your marks above 85 to guarantee an A. Marks above 85 you can guarantee you will get an A. හරිද? Because there are people who have AAB. හරිද? AAB, this B is because something very important. හරිද? මොකද දන්නද හේතුව? that person, this my class sir told those days, මං ගියපු class එකේ sir කිව්වේ, හරිද? That guy, now first you have bio paper නේ. After that you have physics. After that you have chemistry. හරිද? මෙහෙමනේ තියෙන papers තුන. මේ physics paper එක ඉවර වෙලා he came home and he checked the MCQs. ඒ කියන්නේ essay එකක් ලියලා after writing the essay paper without writing chemistry, some guy has released some marking scheme to groups and stuff. And then that guy checked his physics MCQs. More rank than හිටපු එකෙක්. හරිද? More rank than හිටපු එකෙක්. Like top 100 island rank වගේ දාන්න හිටපු එක්කෙනෙක්. This guy. So he checked his physics MCQs and that year the paper was hard. That year paper was different and he was like messed up. And then he only got 35. He got 35. He got 35 MCQs for physics. You know what happened? His result was AA, B. You know what this B is for? Chemistry. This is for chemistry. He got the chemistry prize at school for chemistry. He got the prize at school for chemistry. Guaranteed day. Guaranteed day. He will get like 90s. Why this happened? Because of this. Physics in a mentality. That mentality changed him. He gave up. He was like, I can't do this anymore. Mentality. So I beg you, I tell this many times, please do not check your MCQs at the middle of the papers. Please do not check your MCQs at the middle of the papers because it's very bad. And if something like this happens below your expectations, you will break down completely. And most of you don't have enough courage to bring yourself up. සමහර කට්ටිය නා කමන්නේ මං ඉතුරු එක හරි කරනවා කියලා කරනවා. සමහර කට්ටිය එහෙම නෙමෙයිනේ. They will like give up. At the middle they will give up. So please don't check your MCQs. I tell this again and again to students. Before going to the exam. ඔක් කරගන්න එපා. හරිද? ඒක තමයි මං කිව්වේ. ඒක guarantee කරන්න බෑ. You can't guarantee and it depends on how you go to the war. හරිද? It depends on how you go to the war and perform there. සමහර කට්ටිය ඉන්නවා B එකක් ගන්නවා කියලා හිතාගෙන යනවා exam එකට. හැබැයි බලද්දි A එකක්. Luck and then the papers like the paper which they are given like is like good for you. Like what you have studied only have come to the exam. එහෙම වෙන්න පුළුවන් නේ. හරි. Enough of talking now. Let's go to the question part B. So this is the phase diagram of pure water. Point A, this is Z. Then this is Y, this is X, this is B, this is C. And this is the pressure axis, this is the temperature, this is the pressure. First Roman number, they're asking identify points T and C. People, this is T, and you call this the triple point, right? You call this the triple point. Triple point can be, people, at this specific pressure, and then at this specific temperature, you will see all three solid, liquid, gases together at once. You will see them. So that is what you call as triple point. And then point C, this one. The point C is known as the critical point. Point C is known as the critical point. Why do you call it critical point? People, critical point means this is the critical pressure, this is the critical temperature. People, if you have a temperature above critical temperature, that means you can't liquefy that gas. No matter whatever the gas is, even water vapor. If you have water vapor, water vapor තමයි main phase diagram එක. Water vapor, if you have the temperature above a certain value, you can never liquefy it no matter whatever the pressure you apply. හරිද? මේකත් එහෙම තමයි. ප්‍රෙෂර් එක මේ ගානට විතර තියලා අර ලික්විඩ් එකක් කරන්න බෑ නෙමෙයි මේ ගෑස් මේවද ගෑස් එකක් කරන්න බෑ. You can't convert it to gas. ඒ කියන්නේ phase change එකක් කරන්න බෑ. You can't do that. හරිද? You can't liquefy කියලා කියන්නේ. gas එක liquefy කරන්න බෑ. You can't liquefy the gas. You can't liquefy the gas. Above the critical point. Above the critical point, you can't liquefy the gas. So yeah, that's it. This is called the critical point. C is known as the critical point. Then second one. Define points identified above. This is the point at which solid, liquid, gas is at equilibrium with each other. Point C the maximum temperature and pressure at which gas can be gas can be converted to a liquid. water vapor can be converted to liquid කිව්වත් හරි because this is the phase diagram of water. හරි. So yeah. Then third Roman number. People, if they give a phase diagram, there is a high chance that they will give something like this. Arrange the following in the ascending order of the feature mentioned in C. They're asking about the critical point. Again, who has the largest critical point? People, critical temperature, they will vary. Critical temperature vary based on intermolecular attractions. Based on intermolecular attractions. When you have larger intermolecular attractions, you have a lesser critical point. Lesser critical point. It is inversely proportional. Critical temperature is inversely proportional to intermolecular attractive forces. Intermolecular attractive forces. So larger the interactions, the lesser the critical point you have. So the largest one would be carbon dioxide. They're asking in ascending order. The exam make ascending order. If you have put like this, your answer will be like this. If it is like something like this, you're wrong. Even if this is correct, it should be in the ascending order because I have done it once and then I got it wrong. I got it wrong. Instructions follow කරන්න බැරි හින්දා තමයි ඒකට වැරදි දාන්නේ. It's not like your chemistry is wrong. There you didn't follow the instructions properly. අන්න ඒක හින්දා වැරදි දානවා because A level, I told you A level is not only writing the chemistry paper. It's about reading something, understanding something, IQ and then problem solving and then everything is A levels. එතකොට අර වගේ එකට ලකුණු කපනවා. ඉතින් ඒක කරන්න දෙයක් නැහැ. That is how it is. හරිද? Ascending order means you have to write the least one first. Ammonia and then carbon dioxide and then helium. Then helium. Right? Okay, write this down quickly. Fourth Roman number, identify the lines represented by AT, BT and then CT. People AT කියන්නේ AT කියන්නේ you have to mark X, Y, Z also. X, Y, Z next one you have to mark. However, is this going to be solid? This is liquid. This is gas. Solid, liquid, gas. So AT means solid gas equilibrium. AT කියන්නේ solid gas equilibrium. Solid gas equilibrium. Solid gas equilibrium. Then BT will be solid liquid equilibrium. Solid liquid equilibrium. And then BT and then CT. CT will be liquid gas equilibrium. Liquid gas equilibrium. I feel fishy about this. This is the other way around. People, second Roman number, this is other way around. I'm sorry. Intermolecular attractive forces increase, critical temperature increase. Yeah, I messed up on that. Intermolecular attractive forces is proportional. I feel fishy about that's what I was thinking, like, is something wrong? Critical temperature. This is the other way around. එතකොට මේ largest one is going to be ammonia. I'm sorry about that. හරිද? CO2 helium. Sorry, write this down. ඒ කියන්නේ ඕක හිතන්නේ මෙහෙමයි. When you have larger intermolecular attractive forces, ඒ කියන්නේ imagine two gases, gas particles together, two ammonia molecules together like this, like flowing here and there. If they have stronger attraction, people, then liquid වෙනවා කියන්නේ මොකද්ද? What do you mean by forming a liquid? They will form a bond and then go down, right? That is what you call forming a droplet. හරිද? يعني gases ගොඩාක් එකතු වෙලා මෙහෙම වෙලා droplet එකක් විදිහට වැටෙනවා. එහෙම නෙමෙයි වෙන්නේ මම මේ නිකන් හිතන්න කියන්නේ හරිද ඔහොම එකතු වෙලා වැටෙනවා right so when there is larger intermolecular attractive forces it becomes together easily and then liquefy so for those kind of gases you have to heat it a little bit more to like their critical temperature is more than that then only they can't join together I hope you understand like it is proportional sorry about that right fifth one XYZ X is solid phase this is liquid phase this is gas phase it's like this you start from solid and then clockwise you go solid liquid gas okay solid liquid gas solid liquid gas මේ සමහර කට්ටිය ඉන්නවා like they have asked so much questions like in 1 month can I go from C to A like those kind of questions may and how do I improve like in 50 days all subjects ඔය motivation talk අහලා exam ලියන්න ගන්න කට්ටියක් ඉන්නවනේ ඔන්න ඔය set එක අනිවාර්යෙන් මොකක් හරි කරලා අණ ගන්නවා හරිද ඔය motivation talk විතරක් බලලා යන්නේ හරිද because that person is not there in the meeting currently එතකොට මේ questions කරත් ඉන්නේ motivation කියත් ඉන්නවා අන්න ඔය වගේ set එකක් ඉන්නවා හරිද they don't want to work, but they want to hear motivational speeches and then stuff. They won't work. They will like have that what do you call that mentality of motivatedness for like some while, and then it will go away, and then they are back to the old self. Then sketch roughly the phase diagram of carbon dioxide. People roughly ne andinne kiyanne, so I'll draw it roughly. So this is pressure, Pascal or ATM, whatever. ATM කියලා දාන්නම්කෝ. This is temperature degree Celsius. Something like this. Mark the T point, triple point, and then critical point also mark. Okay, then I'll move into the second structure essay question. Second structure essay question. Energetics. Part A. People get structure essay number 2. Part A. 1 mole of each gases, carbon dioxide and hydrogen were mixed at a constant volume, contained and allowed to react as follows as at a temperature of 25 degrees Celsius. So carbon dioxide and hydrogen react to form carbon monoxide and then water. Calculate the delta G of the above reaction at 25 degrees Celsius. So delta G standard will be delta G products minus delta G reactants. So products delta G carbon dioxide නෙමෙයි carbon monoxide 137 minus 137 ඊට පස්සේ ඉන්නවා water is minus 229 and it is delta G F ne the formation, so you have to write F here. Delta G formation minus 229 and then minus reactants. So reactants will be carbon dioxide and then hydrogen. Carbon dioxide minus 394 and then hydrogen will be 0. So 0 we can just ignore. Now you can put the units with the squared brackets, kilojoules per mole. Without the units, you won't get marks. Please keep that in your mind. Hurry. Then you have to add these together. 9 and 7 is 16. 1 remaining, 3, 4, 5, 6. 2 plus 1, 3. Minus 366 and then here minus into minus plus 394. So 66, 76, 86, 28. 28 kilojoules per mole is going to be the answer for the first Roman number. Part A, first Roman number, 28 kilojoules per mole. Second one, delta S of the above reaction, delta S standard will be delta S F, delta S products minus delta S reactants. So products, carbon monoxide 197.5 plus 188.7 minus 213.7 minus 130.6. So you had to add these things and subtract. $197.5 plus 188.7 plus minus 0.2 minus 213.7 minus 130.6. 41.9. People, you have to put the units here. Metan units දාන්න මතක් කරලා. Joule per mole per Kelvin. Joule per mole per Kelvin units. හරි. හරියට එන්නේ කියලා. 41.9 is 41.9 joule per mole per Kelvin. People, when you have to substitute, you have to put units. Substituting, you need to put units, and then final answer, you have to put units. And the equation you have to write properly. So all of these, you will get marks. Even if you didn't get your final answer correct, if you have substituted correctly, then you are getting marks for this step. For writing this reaction, for writing this equation also, you will get marks. Writing this equation also, you will get marks. Writing this substitution also, you will get marks. But the units should be there. Units should be there. Third one, delta H. So delta G is equal to delta H minus T delta S. So delta H standard will be delta G plus T delta S. Delta G will be 28 kilojoules per mole plus temperature 25 degrees Celsius, that is 298 Kelvin, multiplied by the entropy change 41.9 joule per mole per Kelvin. Put the units, huh? You can put the units. You got delta S as 42.6. You can check the calculation again. Maybe you have done an error. මෙතන minus ඇවිල්ලා මෙතන plus එක ගන්න තියෙන්නේ ඒක minus වෙනවා. හරිද? මම මේක එක step එකක් නැතිව ලිව්වේ. හරිද? You can check again. I have substituted correctly. 188.7, 197.5. Just check your calculation again. Okay, right. So 41.9 multiplied by 298. So you have to convert this joules to kilojoules. Huh? You have to convert this joules to kilojoules, and then you have to substitute and then calculate 40.5. 40.5 kilojoules per mole. 40.5 kilojoules per mole. Approximation 40.48 kilo. That's the third Roman number. Third Roman number. Then the fourth one, they are saying, does the above reaction occur spontaneously in the direction given? But they have a condition. If the system has to be heated above a certain temperature in order to make it spontaneously happen in the non-spontaneous direction, calculate the value of T. Now, first of all, they are asking, does the above reaction happen spontaneously in the given reaction? Because it has a positive entropy change, it does not happen. It does not happen. I'll write it this side. It does not happen. Delta G is positive. Therefore, reaction is non-spontaneous. Mehema handa buluwan. I'm just telling this again and again. Mehema handa buluwan. They will say, does the reverse reaction occur spontaneously? Because you have question practice and then you have done questions similar to this, like for long time, you will be like, okay, delta G is positive, reaction is non-spontaneous. But they're asking the reverse reaction. They're asking the reverse reaction and then you will mess up that Roman number. So please don't do that. For here, it is okay, reaction is non-spontaneous. So yeah. If the system has to be heated above a certain temperature in order to make it spontaneously happen in a non-spontaneous direction, calculate the value of T. Right. People, in order to make this reaction happen spontaneously, you have to make the delta G 0. Again, 0 is my minimum temperature in order to make the reaction happen. So delta G is equal to 0. Delta G equal to 0 when just spontaneous. So then delta H is equal to T delta S. Delta H is equal to T delta S. Now you can substitute the values for delta H and delta S. Delta H is 40 point something, right? 40.5. 40.5 kilojoules per mole. 40.5 kilojoules per mole divided by 41.9 10 to the power minus 3 kilojoules per mole per Kelvin. Kilojoules per mole cancel off. 40.5 divided by 41.9. Calculate. 40.5 divided by 41.9. 0.9665. 0.966 Kelvin. 0.966 Kelvin. 0.96 is make a habit. Sorry, 10 to the power minus 3, and it will become 10 to the power plus 3. So 966 Kelvin. 966 Kelvin. Okay, right. Then, next one, fifth Roman number. Fifth Roman number. Now, this is a different one. Look, following graph illustrates how the Gibbs energy change varies with the composition of the reaction when the above reversible reaction occurs in a given direction. So we are talking about a reversible reaction now. Above reaction when it is like reversible, when delta G is just like 0. What are the values of G1 and G2? What are the values of G1 and G2? How are you going to find that? How are you going to find the values of G1 and G2? People, minus 394, right? The initial one and the final one only you have to find. කියන්නේ G1 කියන්නේ මොකද්ද? Delta G1 කියන්නේ initial නේ. හරිද? Initial entropy නේ. Entropy නෙමෙයි මොකද්ද මේ Gibbs free energy නේ. Delta G1 is equal to carbon dioxide plus hydrogen. Carbon dioxide is how much? Minus 394. Hydrogen is nothing, zero. So minus 394 kilojoules per mole. This is the initial ones. Then delta G2, it is the final one. Final one is carbon monoxide plus water. Carbon monoxide is minus 137 kilojoules per mole. And then water minus 229. 9 and 7, 16, 1 remaining, 3, 4, 5, and 6, 2 plus 1, 3. Minus 366 kilojoules per mole. So G1 and G2. G1 and G2. Then මෙහෙම එකක් වෙන්න පුළුවන්. හරිද? They can give something like this. නිකන් මේ වගේ එකක් දෙන්න පුළුවන්. ඒ කියන්නේ they will give a equation which is out of syllabus in the question. ඒ කියන්නේ question එකේ දෙනවා මේ වගේ. You can't say this out of syllabus නේ එකක් දෙනවනේ. හරිද? You just have to apply the concept. ඔන්න ඔය වගේ එකක් දෙන්න බැරි නෑ. This is one example. They have given this in 2015 part C kinetics. 2015 වෙන්න ඕනේ. Like I remember it as 15. 2015 part C, the log thing, right? That thing, derivation, the derivation of that thing, it is like out of syllabus, but they have given it. You can check that question in 2015. Something similar to that is given here. This reaction is not in the syllabus, but they have given it in the question. So we can't say it is out of syllabus. So, yeah, the change in Gibbs energy change delta G are relevant to any composition of the reaction is given by the following relationship. So delta G in common, like final minus initial, plus 2.302 RT and log K. That will be the delta GR of the relevant reaction. So what is K? K is the equilibrium constant of the reaction. Now people, this equation can be applied only for reactions which are at equilibrium only. When the system is in dynamic equilibrium, deduce that delta G is equal to minus 2.303 RT log K. People, when the reaction is at equilibrium, when reaction is at equilibrium, then delta G is equal to 0. Delta G is equal to 0, right? Delta G equals 0. So we can write delta GR. Delta GR is 0. Delta GR. Reaction nege delta G is 0. Delta GR, delta G plus minus ne, and plus 2.303 RT log K. This one will become 0. 0 is equal to delta G plus 2.303 RT log K. This one will come to the other side. Delta G will be equal to minus 2.303 RT log K. So there you go. There you go. Write this down quickly. seventh Roman number. Seventh Roman number, they are asking us to calculate. They are asking us to calculate the equilibrium constant K. So for the equation, you can write delta G is equal to minus 2.303 RT log K. So log K, when you subject it, log K, when you subject it, you will get, so delta G value is, මේක නෙමෙයි උඩ දැම්මේ මොකක්ද ඒක value එක 28 කියලා ආව නේද කලින්. You calculated it and took as 28, right? So that is the delta G which you have to put kilojoules per mole. And then you divide by minus 2.303 RT log එක නෑ හරිද? And when you minus 2.303 into 8.314 joule per Kelvin per mole multiplied by temperature 298 Kelvin. 298 Kelvin. Okay, so you are getting a minus answer. You are getting minus something. We have to find the antilog of it. You have to find the antilog of it. අර pH වල කරා වගේ තමයි. හරිද? pH වල කරා වගේ තමයි. මෙතෙන්ට එන්නේ people answer එක -4.9 කියලා. හරිද? -4.9 කියලා එන්නේ. ඒතකොට K will be equal to අර pH වල කරේ people. pH වල කරවා වගේ වැඩක් කරන්න තියෙන්නේ. මේකේ antilog එක හොයලා 10 to the power -5 value එකකින් එන්නේ. හරිද? 10 to the power -5 multiplied by 1.25. antilog එක ගහුවම 1.25 කියලා එනවා. 1.25 multiplied by 10 to the power -5. pH වල කරා වගේ වැඩක් කරන්න තියෙනවා. මෙතන minus log කියලා තිබ්බේ people. මේ minus එකේ මේ පැත්තට ගත්තාම minus log කියලා එන්නේ. හරිද? එතකොට මේ ඕකේ antilog එක හොයද්දි 10 to the power -1 තමයි multiply වෙන්නේ. You have to multiply it by 10 to the power -5. Right? You have to multiply it by 10 to the power -5. I hope you understood that. Please write it down quickly. You didn't understand that? Okay, wait. මෙහෙමනේ. දැන් මේක අනිත් පැත්තට හිතන්න. Think this the other way around. You have this answer. K equals 1.25 into 10 to the power -5. You apply minus log for this. හරිද? මේකට minus log දාන්න. Just like pH. හරිද? minus log K is equal to 5 minus 1.25 කියලා නෙන්නේ. 5 minus log of 1.25. මේක දන්නවනේ pH කරලා තියෙනවනේ. pH කරපු කට්ටිය දන්නවා ඔක. හරිද? එතකොට මේක තමයි මේ. හරිද? මේක තමයි මේ කරලා තියෙන්නේ. මේකේ log එක හොයලා තමයි ඔය 4.9 කියලා අවිල්ලා තියෙන්නේ. මේක හුවම තමයි 4.9. log of 1.25 is 5 minus 0.1. හරිද? 5 minus 0.1. එතකොට මේකෙන් තමයි එන්නේ 4.9 කියලා. minus log k is equal to 4.9. එතකොට log k is equal to minus 4.9. හරිද? අර අපි කරන්නේ බිම log අර pH value එකක් අනිත් පැත්ත හරවන්නේ. Like when they say pH is 4.9, what do we do? අර මං කිව්වේ මෙතඩ් එකක් අර 5 minus 4.9 අරගෙන ඒකේ log එක හොයලා ඊට පස්සේ 10 to the minus 5 ගෙන් multiply කරලා අර මම මෙතඩ් එක කිව්වේ pH convert into the concentration of H plus අන්න ඒ මෙතඩ් එක තමයි මෙතන use කරන්න ඕනේ. Like there's nothing like out of syllabus here. Don't panic. හරිද? මේක අනිත් පැත්තට හිතන්නකෝ ඒතර තේරෙනවා. Think this the other way around and then do the method backwards. උඩට. හරි. Then people do you expect any relationship between the value of K and the spontaneity of the reaction at the relevant temperature? Read that again. Do you expect any relationship between the value of K and the spontaneity of the reaction at the relevant temperature? People, equilibrium constant doesn't cause any difference in the spontaneity. Haril? No, මේ equation එක හරි පුළුවන් නේ. Yes, yes, yes. හරි හරි. එතෙන්ට උත්තරේ දාන්න yes කියලා. The reason is people, according to the reaction, delta G is equal to minus 2.303 RT log K, RT log K. Here log K, people, is greater than 0 for delta G is less than 0. Therefore, K is larger than 1. Therefore, K is larger than 1. Therefore, K is larger than 1. This question might be confusing for you people. This question might be confusing for you. If you have any other doubts, people, after the class, you can drop me a message about this. This fan has some issue. People, last Roman number, ninth one. Calculate the ratio of carbon monoxide concentration over carbon dioxide concentration at the composition indicated as in X. Right. How are you going to find that? People, at the composition, hurry, let's write the equation carbon dioxide gas plus hydrogen gas reversibly react to form carbon monoxide gas plus H2O gas. Hurry. Now we can write the equilibrium constant for this. Equilibrium constant of the reaction Kc will be concentration of carbon monoxide gas, concentration of H2O gas. Here we write H2O gas level because it is a gas. Liquid can you remember that? Here it is a gas, so we can write it as gas. Here carbon dioxide, and then this is hydrogen gas. Hydrogen gas. Right. People here, equal amounts of carbon dioxide and hydrogen are mixed together. Are the equal amounts of carbon dioxide and hydrogen are mixed together? Here, 1 mole of each gas is mixed at the beginning of the question. So equal amount is mixed. So the concentration of carbon monoxide and water is the same, right? Carbon monoxide and water is the carbon dioxide and hydrogen. Carbon dioxide and hydrogen. What in? Something is wrong here. 1 mole of each gases, carbon dioxide and hydrogen, were mixed in a constant volume, and the container was allowed to react as fast as possible. As equal amounts of carbon dioxide and hydrogen are mixed, and the stoichiometry of the reaction is 1:1. Yes. People here, the stoichiometry is 1:1. මෙයාගේ concentration එකයි මෙයාගේ concentration එකයි equal වෙන්න ඕනේ. and මෙයාගේ concentration එකයි මෙයාගේ concentration එකයි equal වෙන්න ඕනේ. So they asking the question carbon monoxide over carbon dioxide නේ මේ දෙන්නනේ අහන්නේ. Like this one and this one equal. Like in pH we did like concentration of H plus multiplied by the salt, we wrote it like this CH3CO minus. And because these two are equal, we wrote like H plus squared. Likewise, we can write it for here also. Carbon monoxide gas squared divided by carbon dioxide gas. Here you go. So Kc will be, මෙතන Kc කියලා දාන්න බෑ, K කියලා දාන්න ඕනේ because they have given it as K. Right. Calculate the ratio KO over KO2. So we can find the ratio by taking the square root of K. Right? The K we found before, 1.25 10 to the power minus 5. Square root of 1.25 into 10 to the power minus 5. You can rearrange this. Square root of 125, that would be square root of 125. 11.18. If I take 12.5, that would be easy. 12.5 into 10 to the power minus 6 square root. 12.5 into 10 to the power minus 6 square root. Then the minus 6 you can just divide by 2 and then take the square root. So 12.5 3.535 into 10 to the power minus 6. There you go. So that is that minus 3. So that's the structure essay number 2. That was a bit tough than other questions. That was a bit tough than the other questions. Take the structure essay number 5. Take the structure essay number 5. Structure is a number 5. There are people. A system was prepared by a student to find the combustion enthalpy of hydrocarbon C4H8. Here, the initial temperature was measured as 25 degrees Celsius. This experiment is performed using the data obtained by heating the water in a calorimeter using the heat evolved during hydrocarbon combustion. Like the the common practicals you have done in the A levels, like the same method they have used here also. The initial temperature of the water was measured from 25 to 35, and the volume used was 300 cubic centimeters. Calculate the amount of heat released. Right. So we can calculate delta Q. We can calculate delta Q by applying dVs delta theta. Density 1 gram per cubic centimeter. And the volume, they have given it the 300 cubic centimeters multiplied by 4.2 joule per gram per degree Celsius multiplied by the temperature. Temperature change 10 degrees Celsius. Per gram, gram cancel, per cubic centimeter cancel. Then 42 multiplied by 300 joules. That's going to be 3 into 2, 6, 3 into 4, 12. 12.6 kilojoules. 12.6 kilojoules. That's going to be your answer. 12.6 kilojoules. That's going to be your answer. Then second one. If 0.252 grams of C4H8 was used here, calculate the standard combustion enthalpy of C4H8. Combustion enthalpy you can calculate, people, by dividing the delta Q by the number of moles reacted. Number of moles of C4H8 reacted. You can divide by number of moles of C4H8 reacted, then you can find the delta H. But you have to find this first. How are you going to find that? They have given the mass here. So number of moles of C4H8 will be the mass of C4H8. That's going to be 0.252 grams divided by the number of moles, molar mass. Grams divided by molar mass. So 12 into 4, 4 into 2, 8, 4.14 plus 8, 48, 50, 56. 56 grams per mole. So to 0.252, 0.252 0.252 divided by 56. That's going to be 0.0045. 0.0045 moles. And now you can divide the delta Q. Delta H is equal to 12.6 kilojoules divided by 0.0045 moles. Now you can calculate 12.6 divided by 4.5, 10 to the power minus 3, 4.5, 10 to the power minus 3, and kilo you can multiply by 10 to the power 3. I'll leave it like kilojoules, neither. Then it's going to be kilojoules per mole. Your answer will be kilojoules per mole, but it will be a big value. 0.252 divided by 56. 0.00545 moles. So it is like completely combusted, right? Yeah, that is how you take it. So 12.6 you have to divide by 12.6 divided by 4.5. 2.8. 2.8 10 to the power 3 kilojoules per mole. So 2800 kilojoules per mole. 2800 kilojoules per mole. That is the combustion enthalpy of C4H8. People, be careful when you're finding delta H, you have to put the negative sign in the final answer. Because this is an exothermic reaction, so temperature increased from 25 to 35. Therefore, your answer should be negative because it's an exothermic reaction. So it's better if you can put it here itself. So it's negative 2800 kilojoules per mole. Negative 2800 kilojoules per mole. The Gibbs energy change here was calculated to be minus 9.8. Minus 9.8 at temperature 25 degrees Celsius and 180. Find the standard entropy change of this reaction. People, delta G is equal to delta H minus T delta S. We can apply this equation. Gibbs energy change is minus 9.8 kilojoules per mole is equal to delta H minus the temperature 298 Kelvin and entropy change only you have to calculate. All right. So when you bring this onto the left hand side, so 298 times delta S is equal to delta H plus 9.8. Enthalpy change you calculated before minus 2800 kilojoules per mole, and this is 9.8. Delta S will be minus 2800 plus 9.8 divided by 298. Final answer you're going to get joule per mole per Kelvin. Kilojoules per mole per Kelvin. I think there's no error with this value, right? The answer seems kind of deviated. (2800 minus 9.8). 2790.2 divided by 298. That's a 9.63, 9.363, 9.363 minus 9.363. I'm not sure about this answer, people. The calculation, you can check it out. I'm not sure of this answer which I got. I have used the values they have given here. Minus 9.8 kilojoules per mole. And the standard entropy change you have to calculate using this equation, my method. This is the correct one, and you have to look whether the final answer is it correct or not. Like according to your calculations and stuff. The final answer minus 9.36. I hope that is the one which you will get. Fourth Roman number, it was found that experimental enthalpy value was different from the true value. State two possible reasons for this difference. The first one is error in measuring the temperature, error during measuring the temperature. So when you're doing this practical, people, you have to put the thermometer inside and then the temperature reading could change. We can't be like very like specific with the temperature change. So the temperature measured could be different. So they are right, the first one. Error during the temperature reading. 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 Second one, heat loss to the environment. Heat loss, heat exchange with the environment. Heat exchange with the environment. When you write heat exchange with the environment, people, if it's like endothermic or exothermic, doesn't matter. It's like heat exchange. So you will get marks for that. That's a trick which you can use for physics also. Physics practicals, heat exchange with the environment. So that's another reason. for getting a different answer. Fifth one, using a plastic container here is far more suitable than using a calorimeter. Explain the reason for this. You can write two reasons for that. The first one is plastic is a better insulator. Plastic is a better insulator. Plastic is a better insulator. Second one, plastic has a lower specific heat capacity. Plastic has a lower specific heat capacity. So people may, the reaction doesn't give its enthalpy change to the calorimeter එකක් ගත්තාම like it gets heated up quickly and then it's like metal නේ, it's a metal නේ, so it has a larger specific heat capacity. But plastic is not like that. Plastic has a lower specific heat capacity and because of that we can use plastic.